AGPS TV. I am grateful that you've joined us, and if you have done so, it's a hope and it's a view that you're going to find once again these tutorials very helpful. Now, the last time we met, I had retreated that there are some numbers that are very important, which are most often retreated, or they are most often referred anytime that we are dealing with set problems. And if you may recall, I mentioned a number of some. One of them being factors, prime numbers, odd numbers, even numbers, and so on and so forth. Now, if you have been able to, as it were, grab this concept of set of numbers, then today I would like to take you through types of set, which is also key for a full understanding of this topic. And for types of sets, I'll be dealing with a number of them. And as I've done in my previous presentation, I am going to take you through an activities, then we come to a definition. Now, for a set, I am going to first of all start with finite set as the first type of set. Now, when we say finite set, what does finite set implies? Now, when I ask you to tell me the multiples of 3, the last time I said that multiples are the set of numbers that a given number can divide without a remainder. So when I ask you to tell me the multiples of 3, then you are likely to tell me 3, 6, 9, 12, and you continue to mention these multiples to such a time that you may not be able to find the last digit or the last member. You can talk into threes. Now I have reached into tens. I'll go into hundreds. I'll go into thousands. I'll go into tens of thousands. We can even go into quintillions. And yet, the last member cannot be found. Once again, when I ask you to give me the set of even numbers, you are also most likely to give me 2, 4, 6, 8, 10, and so on and so forth. So clearly, you know that there are certain types of sets. When you are asked to find 8 members, it will be difficult for 8 last member to be identified or found. And such a set is what we refer to as infinite sets. But let me come back, and we are talking about a finite set. Now, for finite sets, if you understand the concept of infinite sets as a set which its last member cannot be found, then we are going to say that they are set which its last member can be found. And so today, we are dealing with finite sets. And so for finite sets, we are saying that these are sets which its last member can be found or can be identified. For example, if I ask you to find the sets of even numbers between 2 and 20, the set of numbers which are even between 2 and 20. So if you want to write sets which are even numbers between 2 and 20, and you are supposed to write them. Then you are going to have 4, 6, 8, 10, 12, 14, 16, and then 18. So you discover that when we are talking about finite sets, and you are asked to find a set of even numbers between 2 and 20, this is going to be your set. And for this to be your set, it means that we can identify the last member, which is 18. Again, if I want to find the first 10 multiples of 3, the first 10 multiples of 3, the first 10 multiples of 3, if I want you to find the first 10 multiples of 3, then once again, we are also most likely to have 3, 6, 9, 12, 15, 18, 21, 24, 27, and then 30. So these are the first 10 multiples of 3. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Once again, the interest is with the last member. And so whenever you have a set that the last member can be found or identified, then we can safely say that that set is a finite set. So anytime you have a set which the last member can be found or identified, then we conclude that that set is a finite set. However, like I've said earlier on, if I have a set of multiples of 3 and a set of even numbers, then you also know that the last member can neither be found or identified. Therefore, we say that set is an infinite set. Then we say that that set is an infinite set. So infinite set is simply put to be set which its last member cannot be found or identified. And then we are saying that finite set are set which its last member can be found or located. And so I want you to take your pen and write a number of sets and group them as either finite or infinite sets. For finite sets, you should make sure that the last member can always be found. And for infinite set, it is a set which its members will go on and on and on without its last member being identified. Now, aside finite and infinite sets, we have other types of sets. And the next type of set I want to deal with is I want to deal with a null sets. A null set. And another name for a null set is an empty set. So we have a null set or empty set. Now, as the name implies, when we say something is empty, what does it mean? When we say empty, it means that something that contains no elements, no objects, no member. But in sets, when we are talking about members of sets, we are most likely to use the word elements, or you can simply call it members. And so when you have a set with no member, then we say that set is a null set or an empty set. For example, let's look at a class of 30 that a teacher has asked to meet in an afternoon classes. The teacher goes to the class and discovered that none of the students attended classes for that day. So out of the 30 students in a class, the whole place is empty. Not even a single student has attended the lectures. For any reasons, maybe they were tired, the teacher is not so good, so the students want to skip that class. So for any reason, the class is empty. And so we say that that class has no member at all. Therefore, we can safely say such a class is an empty class, or better still, a null set. So when we say a null set or an empty set, we are basically talking about a set with no member. Then again, I've seen a pastor who has praised to God that he wants the auditorium, the church auditorium, to be full. And then when he has prayed and he has prepared well, all of a sudden the rain sets in. It rained so heavily that there were thunderstorm and lightning. And as you can see in Africa, when there's such situation, there's lights out. But the pastor, with faith, went to the church auditorium with the belief that he's going to meet some church members, only to find out the door is not even open. And when he has opened the church door, the whole place is empty. There was not a single member in the church. And because there was no member in that church, at that setting, the church becomes an empty set or a null set. So simply put that a null set is an empty set or a set with no member at all. I hope you have found my illustration and my explanation fairly useful. Then aside a null set, we also have a unit set. A unit set. Now, even if it is not math, and then you use or you come across the word unit, it simply depicts one and one only. When we say by, we are talking about two. When we say try, we are talking about three. And so when we are saying mono, mono is one, or you can call it unit, which is one. So when we are talking about set, and we are talking about unit, which is one, then definitely you agree that when we are talking about a unit set, per my definition, you can talk about a set with only one member. A set with only one member. But let me go back a little, and then we come to the null set. Let me take you back a little, and then draw your attention that unit set is illustrated in a curly bracket, in a curly bracket without any member. The reason why I've taken you through this again is that sometimes you see a student with a set and a dot or a point inside this set, and when you ask the student what type of set is this, they tell you it's an empty set. Now don't forget that the members of set can be anything. It can be set of trees, it can be set of people, it can be set of alphabets, and it can also be a set of punctuations. So let us take a full stop as a set of punctuations. So if you have a full stop, then it has one member. So when they tell you what type of set is this, so long as there's something inside the set, then we can safely say this is a unit set, because it is a set with a member and not a null set. Sometimes you also put another set and you put 0 inside it, and they tell you because 0 is 0, they tell you that it's an empty set because there's 0 inside. But don't forget that 0 is a whole number, and therefore it's a set with a member of 0, and therefore we call it a unit set. So long as there's one member inside, it is a unit set and not a null set. And not a null set. So that is the emphasis I want to place. That when we talk about a unit set, we are talking about a set with a member. And when we see a set like this, please do not misguided to say it is an empty set. So I have said that a set of members or set with only one member is a unit set. So let us come back to my earlier illustration of the pastor who went to church without a member. Let us assume that for any reason, the pastor went to church to see the church elder who always wants to go to church. A typical example is Mr. George Efron, a very stand Christian. No matter whether it rains or it shines, even if it rains fire and rainstorm, he will still attend church. So for that reason, if that church member goes to find Mr. George Efron, who is a stand Christian and never want to miss a church for any reason, and he happens to be the only member in that auditorium at that time, then we say that the member or the church has got a member. And so we say that set becomes a unit set because it's a set with a member. And I hope once again you have liked it, and may you be fruitful as we enter into our journey of mathematics. Aside a unit set, I also want to talk about another set. And that set that I want to talk about a union set. Another type of set I want to talk about is a union set. I hope you are writing them down. You are writing them down. I'm talking about a union set, a union set, a union set, a union set. And so if you have a union set, now let me also do an illustration for you. Go back to school. You see that we have different classes. For example, this is AGPS TV. That is meant for junior high students. And so for your school, I believe you have junior high school 1, junior high school 2, junior high school 3. So we have 3 different classes, so we can have 3 different sets. So let us assume that we have set JHS 1, then we have another set JHS 2, then we have another set JHS 3. So we have these 3 sets. These are 3 different classrooms. But the headmaster decides to call for assembly. And so when they ring the bell for assembly, you see JHS 1, JHS 2, JHS 3, all these 3 classes coming together. And so when you put these 3 different sets together at the assembly, then we are talking about a union set. It means that you are putting individual sets together. And so when you combine them, then the assembly will become a set of JHS 1, a set of JHS 2, and a set of JHS 3, all being put under one assembly. And so when we have such a set, then we are saying that this is a union set. So by definition, we are saying that a union set is the addition of 2 or more sets put together, or putting 2 or more sets together forms a union set. Now let me give you a proper example so that when you're asked to have a union set, you will understand it better. Union set is denoted by this symbol. Please, let me retreat that this symbol is not you. Don't say you. This is a symbol that depicts a universal set and not letter U. And so let us assume that I have set a set of the first 5 prime numbers, a set of the first 5 prime numbers. So I have 2, I have 3, 5, 7, and then I have my 11. So these are the first 5 sets of prime numbers. And then I have B as a set of odd numbers. I told you that these sets are very important and they will be referring to them. And as I'm doing, that is why in my previous lesson, I took pains to take you through. And if you have not watched that video, you can go back and watch it again for a clearer understanding to this concept. So for a set of odd numbers, that is, say, the first 5 set of odd numbers. That one also have 1, 3, 5, 7, and then 9. So we have set A, and then we have set B as a set of first 5 prime numbers and first 5 odd numbers. And so a teacher asks you to find A union B. So it will be put as A union B. So when we say A union B, it means that put the two sets together. Put the two sets together. And when we are putting two sets together, each member is written once. Each member is written once. So for A union B, we are going to have 1, 2. Even though we have 3 in set A, we also have 3 in set B, but I said members are written only once. So I'm going to write only 1, 3. Then once again, I'm going to have only 1, 5, only 1, 7, and only 9, and then 11. So you see that if you come to set A and set B, all the members can be found in A union B. In other words, when you put the two sets together, all the members must be seen in the union set, because all the students are expected to be at the assembly ground. If you have also noticed, I have written all the numbers in ascending order of magnitude. In ascending order, I simply say that their numbers are ranged from the lowest to the highest. I must say that it is also not wrong when you decide to arrange your sets in descending order. That is, if you want to do it from the highest to the lowest. In both arrangements, you'll be marked right, and you are going to be correct. Even when we decide to mix them, but we encourage students to try as much as possible to arrange their members in only 2 ways, either in ascending order or descending order of magnitude. And so that brings us to a union set, a set putting 2 or more sets together. Another set that I want to talk about is equal sets. Equal sets. I told you that we have a number of sets and I want to run you through them. But I want to do it in such that you will find it helpful. So I am going to once again take you through an equal set. An equal set. Now, let's consider these two sets. Set A. Set A, we have 1, 2, 3, 4 as set A. Let us also consider set B. Set B to be 3, 1, 4, and 2. Consider these two sets critically. 1, 2, 3, 4, and 3, 1, 4, 2. You will identify that each set has got 4 members. 1, 2, 3, 4. So let us use n to represent the number of members. So we say that n for set A as the members, number of members, is 4. And then for set B, we also have n to be 4. So first of all, you see that set A and set B have the same number of members. The same number of members. And if you also check the members individually, you can also match them. You can match 3 to 3. You can match 1 to 1. You can match 4 to 4. And you can also match 2 to 2. So clearly, you identify that they don't just have the same number of members, but they also have the same members. They also have the same members. So we say that any 2 or more sets with the same number of members and the same members are called equal sets. When 2 or more sets have the same number of members and the same members, then we can say that these 2 sets are equal. So simply put equal sets to be 2 or more sets with the same number of members and the same members. I have said that in sets, the individual members are called elements, or you can simply call them members. So we have 2 names. Either you call them members or you call them elements. And these are standard names that you can use. So in some places, you may decide to use members for it. In other ways, you can decide to use element for it. In both 2 ways, they are accepted. And you can use them interchangeably because they are synonymous to each other. So let us consider these 2 sets and say whether they are equal set or not. So let's see set C. Or simply say C. We have A, B, C, and D. And then we have set D. We have A, B, C. Let's consider these 2 sets. Now, may I remind you that the name of the set we use block letters or capital letter to name a set. And the members or elements we use small letters. You cannot use capital A to write a member of a set. So anytime you are using letters to write members or elements of a set, be mindful to use small letters. And the name of the set, you should always use a capital letter to name them. Now, are these 2 sets equal? Set C and set D. I have said that for 2 sets to be equal, they must have the same number of members and they must have the same members. So count set C, the members. You see that it has again n is 4. But set D, we have only 3. And the first evidence even concludes that because they don't have the same number of elements, then we say they are not equal. So we say set C is not equal to set D. So you can write it this way, that set C is not equal to set D. So we have equal, then we slash through it to say that set C is not equal to set D. Again, even if we decide that they are 4-4 and we cannot match the individual members like I did, I can match A to A, I can match B to B, I can match C to C. But because I cannot match D in set C to any other member in set D, then once again we conclude that set C is not equal to set D. So for set C to be equal to set D, they must be set D must also have a member of D for it to be equal. For it to be equal. So that is for equal sets. Now I want to talk about equivalent set. Equivalent set. Equivalent set. Equivalent set. Equivalent set. Equivalent set. Now, once again, I want to take you through an activity for us to draw our conclusions. So let's consider set X. Again, we have members to be A, B, C, and D. For set X, we have A, B, C, and D for set X. Then I have set Y to be 1, 2, 3, 4. So I have these two sets. Set X and then set Y. Set X as members as A, B, C, and D. And then we have set Y having members 1, 2, 3, 4. Now, what is common to these two sets? If we count the members of set S, you see that our N is 4. And when we count the members of set Y, our N again is 4. So you see that both set S and set Y has the same number of members. The same number of members. But the question I'm asking, are the members equal? Are the members equal? The answer you probably give me is no. For the members to be equal, set Y should also be A, B, C, and D. But because it is not A, B, C, and D, and it is just 1, 2, 3, and 4, we say that the members are not equal. But the number of members are equal. So we say that any two or more sets with the same number of members, but not the same members, are called equivalent sets. So for equivalent sets, the number of members are the same, but they don't have the same members. But they don't have the same members. But they don't have the same members. Let us consider set A again. And let us have 2, 4, 6, 8, 10. And then set B. Let us have 12, 14, 16, 18, and then 20. So we consider set A and then set B. We have 2, 4, 6, 8, 10. And then we have 12, 14, 16, 18, 20. Then we count the number of members. So when we count, we are going to have 1, 2, 3, 4, 5. So we have our N to be 5. And then the B, we are having 1, 2, 3, 4, 5. So both the number of members are 5 each. But the members, once again, are not the same. So we also conclude that these two sets, they have the same number of members, but not the same members. So the definition of equivalent set is true. And so we say that these two sets are equivalent and not equal. They are equivalent and not equal. Now, I want to talk about a union set. Sorry, I have talked about union set. I want to talk about universal set. Universal set. Universal set. When we talk about universal set, let us have 3 sets. Say set A, 1 and 2, Set B, 2, 3, 4, 5. And set C, we have, say, 6, 8, 10, and then 12. So, I want to talk about universal set. This is the set I want to talk about. Now I have 3 sets. When I put all these sets under consideration, when I put all these 3 sets together, or when I consider all these 3 sets, then we are talking about a universal set. So the universal set is the mother set. It is through which all other sets are born. So every set is born from the universal set, because every set we are putting them together. For example, if you come to Ghana, we have 16 regions. We have greater, what do you call it? We have Ashanti region, we have Greater Accra region, we have Oti region, we have Ahafo region, we have so many regions, 16. These are individual regions. And when we put all the 16 regions together, we are going to have a mother set. And the mother set is Ghana. So Ghana is the universal set. And in Ghana, we have different regions. So 16 regions. And when we put 16 regions together, we have a universal set. So when we say universal set, it is all the sets put together. Again, if you come to my school, for example, AGPS, that is Abundant Grace Preparatory School. We have the nursery department, we have the KG department, we have the lower primary, we have the upper primary, and then we have the JHS. These are individual sets. But when we try to put all these departments together, we have Abundant Grace School. So Abundant Grace School consists of all these departments I have just outlined. And so we call it a universal set. So the universal set is the bigger set or the mother set through which all the other sets are built. Now, so I am going to put the universal set together. And once again, we used a big symbol like this for universal set, just the same as the union set. And you can use the union and the universal set as a replacement. And so if I decide to have my A union B and then union C, and I want to put this set together, I am going to have 1, 2, 3, 4, 5, 6, 8, 10, and then 12. So these are the A union B union C. In other words, we can simply call the universal set U for A union B union C. Very soon I'll be dealing with properties of set. So I'll be dealing with such a set. And then when it comes there, I'll talk much about this. But I don't think it's going to be the lesson for today. And that is why you need to subscribe and hit the bell button so that as and when we are having these live tutorials, you will be reminded so that you will not miss any of the lessons. And once again, if you have any challenge with my lesson, you can go back and watch the video again. I would like to talk about subset, and that is where possibly I will end my lessons today. The reason why I want to end at subsets is that this is where a lot of people have challenge. And that challenge always makes them get answers wrong. This subset, anytime you tell students to write subsets, I don't know whether it is a problem or something, but it's a challenge. But today, I want God to use me as an instrument of blessing to solve that challenge. So I want you to listen to me carefully. Now, let's consider set A to be 2, 4, 6, 8, 10. Let's consider set A. 2, 4, 6, 8, 10. Then we also have set B. And set B, we have say 2, 6, and then 8. So we have two sets. Set A and we have set B. Now consider set B. You realize that all the members in set B can be found in set A. All the individual members, when you match them in set B, if you match it against set A, then you see that all the members in set B can be found in set A. But not all members in set A can be found in set B. Therefore, we say that the B is a smaller set and the A is a bigger set to the set B. So when all the members in set B can be found in set A, then we say that B is a subset of set A. B is a subset of set A. So we write it as B is a subset of set. B is a subset of set A. So the smaller B comes, then we have a symbol for subset. Please, this is not C. It's a symbol for subset. So we say B is a subset of A. Or you can say that A contains B. We read this as A contains B, or B is a subset of A. You can put these two statements and anyone you use will be correct. We say that B is a subset of A because all the members of set B can be found in set A. All the members in set B can be found in set A. Now, let us also consider this. Set C. Let's consider set C to be A, B, C, and D. And set D is simply a unit set. A unit set. Now, if set D has only one set, and that member can be found in set C, then we say that set D again is a subset of set C. So we write D being a subset of set C. Forgive me for using almost the same identical unit. So for the purposes of clearer understanding, let me change my set C to say F, so that I have my set D and set F, so that it will be clearer. So from here we say that set D is a subset of set F, so that this is much clearer, so that you will not confuse yourself with it. So that is for subset. Now, I have said that when we talk about universal set contains all the sets. In other words, let me assume that I have U. I have U being the universal set, and my universal set is 1, 2, so these are the set members of set U. Now, if this is the universal set, any other set I will mention will have to come from this set. will have to come from this set. Any set you write that its members cannot be found in the universal set will not be correct. And this is where students have the difficulties. Sometimes you have a question. They say that if U is the universal set and set A is a set of odd numbers, and then set B is multiples of 3. I told you that I'll be referring to these, and that is why, once again, you have to go back. If you missed my earlier teaching, you must be watching some of these things. It will be very helpful to you. Now, we have set A as set of odd numbers, and set B multiples of 3. As soon as students see set A to be odd numbers, they began to write. As soon as they say that B is multiples of 3, they write and put 3 dots, because Sir Hanone has just said that multiples are infinite sets. And so they want to show the teacher that they know. But anytime they give you a universal set, set for a statement, and that statement will always be set A and set B are subset of the universal set. Set A and set B, they will always link it to the universal set. So they will always tell you that set A and set B are subset of the universal set. The moment they tell you that set A and set B are subset of the universal set, it means that go to the universal set and pick all the odd numbers for set A. Go to the universal set. Don't just write any odd numbers, but all the odd numbers that you're writing must come from the universal set. And all the multiples that you're going to write for 3, they must be members of the universal set. And so for my set A, if I want to write my members, what are the odd members in the universal set? It becomes 1, 3, 5, 7, and 9. These are the only members. And because all the members in set A can also be found in set U, we say that set A is a subset of the universal set U. So please, when you write any member which is not in the universal set as your set A, you are going to be marked wrong. Because we have just said that set A should be a subset of set U. My advice is that when you have the question, take your time. Understand the full demands of the question before you start. I have seen a number of students, as soon as they see odd numbers, they write 1, 3, 5, 7, 9, 11, 13, 15, 16, and when they are tired, they write 3 dots, expecting to score. Please. The set, as soon as we are giving universal set, we will always say that the other sets are subset of the universal set. Then, so for that, we come to set B. And if we want to write our multiples of 3, we are coming into the universal set again to write our multiples of 3. And so we are going to have our 3, our 6, and our 9 as the multiples of 3. In that case, it makes set A and set B a finite set. It makes it a finite set because its last members can be found. I hope you are finding it very helpful. Please, do not just be writing multiples just because you want to write it. But make sure, since I've said it's a subset, all the members can be found or identified. Now, where I want to end is sometimes they ask you how many subsets can be formed from a given set. How many subsets can be formed from a given set? How many? So if you have set A, set A to be A, B, and C, to be A, B, and C. Then they ask you, how many subsets can we form from set A with members A, B, and C? How many subsets? I have seen it in a number of BEC past questions where students have been given a set and they are asked to find the number of subsets they can be found from. And if you want to find the number of subsets, it is simply given by 2 power n. 2 power n. Where n is the number of members in a set. I have said that whenever we are using n, we are talking about the number of members. So where n has, or n depicts the number of members. So for set A, we can safely say that our n is 3. So we are going to say our n is 3. So for us to be able to identify the number of members we can form from this set, the 2 is always constant. And so we are going to have 2 exponent 3. This is called power or exponent or index. It simply tells us the number of times the base multiply itself. This is the base, the 2, and the power is 3. So this is telling me that the 2 is multiplying itself 3 times. Let me also retreat that most students assume that the power is addition. So instead of them to multiply, they add. Please, we are multiplying. So we are going to multiply 2 3 times. So we are going to have 2 by 2 by 2. And once again, it is not addition. I have seen students write answer equals to 6 because they add 2 plus 2 plus 2. But this is 2 times 2 times 2. And 2 times 2 is 4, and 4 times 2 is 8. What it means is that for set A, we can form 8 individual sets from this given set. And finally, if I have set B, and I have members to be 1, 2, 3, 4, and 5. And then you are asked to find how many subsets we can form from this set. We simply again have 2 power n. So we count n to be the number of members. So we have 1, 2, 3, 4, 5. Therefore, our n is equals to 5. It means that we are going to have 2 raised to the power 5. And so we are going to multiply 2 by itself 5 times. And so we are going to have 2 times 2 times 2 times 2 times 2. So we have 1, 2, 3, 4, 5. And our answer is going to be the number of subsets we can form. And so 2 times 2 will give us 4. 4 times 2 will give us 8. 8 times 2 will give us 16. And 16 times 2 will give us 32. So it means that if you have set B, 1, 2, 3, 4, 5, it means that we can form 32 different subsets from this set B. Next time when we meet, I am going to teach you how to form them, because they will ask you to form them. It is not all the time. They will ask you to find the number of subsets you can form. Sometimes they ask you to form them. How can you form all the 32? And how can you form all the 8? Make a date with me on Wednesday, and I'm going to take you through it. And you see how it will be done. Once again, if you are watching and then you have not subscribed, you can subscribe to the channel. Inform others to watch. Your friends at this time of COVID-19. They need it. As I've mentioned COVID-19, please stay safe. Practice social distancing. You must do well to wash your hands as frequently as possible. Use alcohol-based hand sanitizers. Make sure that if you have nothing to do, please Stay home. I need you. Your family needs you. Ghana needs you. Please, you are the future leaders. My name is Samson Anani. The next lesson is going to be science. And I hope you stay back and enjoy the lessons. He's a very brilliant teacher. You are going to join it. Join me again as I come on your way. May God bless you and have a sweet day.